Hello, this is second video of the binomial expansion series. In this video I'll just taking it the bit further. We'll be mixing it with so validating powers with partial fractions. So what I'm going to do, so the agenda of this video is I'm going to recap what partial fractions are, and then I'm going to go through an example and point out the general tips, well, things to watch out for basically. And then I'm creating another video later on with some exercises. So if you're following the C4 Edexcel workbook in my class, it's that one. If you're not, don't worry. I'm not going to go through any questions in this video, but in the next video I'll be doing exercise 2.1 and some of the past paper questions. But again, for this video I'll just be doing an example we'll go through together. That's not in there. Okay, so as I said, I'll recap what partial fractions are. Now I'm not going to go through an example of a partial fraction because we're going to do that in this video, but I'm just going to recap what they look like. Okay, so say we've got an example here of 3x plus 2 over 6x squared plus 2x plus 1, and that would be, so I do some kind of factorised form. 3x plus 2, 3x plus 1. I think that's actually the factorised form of what I was doing. It's pretty good. So we've got two linear factors here. It's just an example, by the way. And I'm going to go through it, but I'm just going to show you what it looked like. And then we've got a coefficient a over the first linear factor, which is 3x plus 2, plus b over the second linear factor, which is 3x plus 1. So that's what a general partial fraction would look like. Now you might have ones that have linear and non-linear factors, so that could be a cubic or a quadratic on the bottom. But one thing to watch out for in a partial fraction, again I have covered this in my partial fraction video, but just to jog your memory, if the power on the top is equal or the same as the power on the bottom, you've got an improper fraction, so use algebraic long division, simplify it down, and then use the power there. What you simplify it down over the remainder of the original fraction. The remainder is what you split up into a partial fraction, as that will now be a cubic, or has gone from a quadratic to a cubic, etc. So again, that's what a algebraic a partial fraction would look like, and that's kind of what we're going to be adding to our knowledge of binomial expansion. Now I did say, just to recap again, the last video we mentioned about validility and how to say if a binomial expansion was valid or not. You just say if a is between, for the n power, so the power outside the bracket, if that is not a positive integer, so either positive but a fraction, or negative and a fraction, or a complete negative number, so a negative whole number. Basically what it's saying, if it's not, and if it's any of them, or not a positive integer, positive whole number, then the value of a or x, the little 1 plus a bit, the a bit of that, if that is equal, that is between -1 and +1, you rearrange it to get your official range. And then we sort of talked about how we recapped some C2 stuff, and we said, how can we turn a fraction, say 3 plus 2x into 1 plus a, and I discussed how we did that. Again, if you're not sure how we did that, just nip back to our other video. So, concentrating on this one now. As I said, we're going through this one. We're going to apply our knowledge of partial fractions to our current knowledge of binomial expansion. Okay, so go through an example here, sort of similar to what we just did there, in terms of two linear factors. So it's 5x take 1 over 2 take x, close brackets, open another set, 1 plus x, close brackets. that is equal, so actually it's best to tell you the question first. Okay, so we'll just call this question 1 because we're only doing one question, you don't have to. But the question says, in ascending powers of x, so that's increasing powers, so express that in ascending powers of x up to the term of x squared. So it's telling you what range to use the binomial expansion, because obviously when it won't tell you to use binomial expansion, you've got to realise express that. And now as soon as you see that, you think, okay, there's two linear factors on the bottom, you've got to do something with algebraic fractions. And then when it mentions in ascending powers of x up to the term x squared, now there's no other thing you do in maths where you expand something to the term of x squared, up to a certain term without it being involved in some kind of binomial expansion, or as far as you're concerned. And state the range of values for x which is valid. Now as soon as it says for what x which is valid, you should know we're going to have to do some kind of validility. So, and the only thing that again that involves that is binomial expansion. So if you didn't get it from the first hint of expanding up to the term of x squared, you surely should have got it from the valid bit at the end. So I'll just reiterate that question. Express that fraction we got on board in ascending powers of x up to the term of x squared, binomial expansion hint there, and state the range of values for x which it is valid. Again, another binomial expansion hint there. The only thing that you might have missed is the partial fraction there, but it will become quite apparent when you start to do binomial validility that you need to do something in partial fractions on that one. Okay, so what we said before is we said when we're simplifying a partial fraction, it's a over the first linear factor, 2 take x, plus, now when we've got the coefficients, you don't immediately write plus because b could be negative obviously, so again that's something to watch out for. B over the second linear factor, which is 1 plus x. Okay, so then what we simply do is, I'm not going to go into too much here, I'm just going to write the simplified version of the algebraic fraction, C3, partial fraction, sorry. Again, if you're not sure how we just do this here, then nip back to our partial fraction video and you should be able to get it. So what we're going to do is multiply both sides by the denominator. As I said, I'll explain it, but I'm not going to go through it. And then it's going to be a times 1 plus x plus b times 2 take x. And then what we need to do is we need to get rid of a or b on each occasion. So x is minus 1, because obviously that will get rid of a. Then we substitute x is minus 1 in. 5 times minus 1 is minus 5. Take 1, minus 6. Gets rid of a, so we could just write a times 0 or just ignore it. Times plus, so we've got b times 2 take x. Now x is minus 1, it's 2 take minus 1, so it's plus 3. So it's 3b, or b3. Divide both sides by positive 3. b equals negative 2. Do the same for finding a, so we need to make b equal to 0. So if we make b equal to 0, then what would make 2 take x equal to 0? You could add x to both sides, so x equals 2, if you couldn't see it straight away. So if x is 2, then we sub 2 into 5x take 1, so 5 times 2 is 10, 10 take 1 is 9, and that equals, that gets rid of the b, so we don't have to worry about that. 1 plus 2, a times 3, so that's 3a. Divide both sides by 3, 9 divided by 3 is 3, 3 divided by 3 is 1, so that's a equals 3, or 3 equals a. Now what I tend to do here is if you've got some kind of highlighter, highlight your value of b and your value of a. Just so when you rewrite it out, because this is the next step to do, you rewrite out 5x take 1 over 2 take x. But you don't have to rewrite this step, this is just, in my mind, this is not key to actually working it out, but just so you know where you're going. If you do make a mistake, you can know from this point on if you made a mistake somewhere here. So it's subsectioning it out essentially. Again, if I've just spoken a tosh, you just ignore me. So we look at our value for a, so that's 3 over the first factor, so 2 take x, plus b, which is minus 2. That's why I shouldn't have wrote plus there, just highlight my mistake. Take 2 You could write plus and then minus 2, but they just turn to be a minus, so it's pointless. And you might get knocked down for your precision. So that's what it equals, okay? Now, what I'm going to do is I'm going to ignore this bit here, so obviously if you wrote it down, you don't need to rub it out, but I'm going to, just because I can. And now, what we said before, we have to cast our minds back to what we said in the first video, and we said if something's over it, it's the power of minus 1. Now what we've got here is 3 over 2 take x, and take away 2 over 1 plus x. So, we rewrite this out as our form. So, a reminder of the question, just in case you haven't got it down. It says, in ascending, express that fraction in ascending powers of x up to the term of x squared, and state the range of values for which x is valid. Now, obviously, the first thing we had to do there is we had to split this up into some kind of partial fraction, because to use binomial expansion, we can't just use binomial expansion on the first fraction that we got given, because as you know from the binomial expansion, it's 1 plus a to the power n equals 1 plus na or an, and then you include the rest of the equation, etc., and it comes clear, quite apparent, you can't use that for that. So that's why we had to split it up into 2 partial fractions, which we could then simplify as, because it's something over 2 take x, the denominator becomes the power of minus 1. So this 3 over 2 take x, take 2 over 1 plus x, is the same as saying that original fraction of 5x take 1 over 2 take x, 1 plus x. It's the same thing. I've just crossed it out. I did write it before. So if you want, what we're going to do now is simplify that. So 3 times 2 take x to the power of minus 1, take away 2 1 plus x to the power of minus 1. So what we do next is, because what we want it in is we want it in the, because we're going to use binomial expansion on this, what we need is, we need it in the form of 1 plus a, or 1 plus x, or whatever, 1 plus 3x. And because we're still trying to find out the validility, first what we need to do is expand that using a binomial expansion, and then go back to this part to assess if it's valid or not, for what range of values they are valid. But, so it's sort of 2 questions in one, this. So what we've done is we've put it into partial fraction, and then what we could do now is, because it says check for the range of values which it is valid, and we could just stop there and do the range of values which it is valid. But I think because we're already going that way, it's easier just to use binomial expansion to expand it up to the term of x squared, as the question asks us. Okay, so what we need to do is, this fraction's alright, this 2 brackets 1 plus x to the power of minus 1, because that's the same as 1 plus a to the power of n, and n just minus 1. But this first part isn't. So what we do is we do 3, and then I'm going to do square brackets, because we're going to take 2 out of here. So it's 2, and then what do we times 2 by to get 2, which is 1. And then what do we times 2 by to get minus x, it's x over 2, so it's minus x over 2, sorry. And then that is all to the power of minus 1. And I'm just going to rewrite this other part of the equation in, just so you're not losing it. Don't mean the will to live, hopefully, I just meant part of the question. So what we've done there is then we've just done all that to the power of minus 1, sorry. And because it's 3 times 2 to the power of minus 1 times 1 take x over 2 to the power of minus 1, anything to the power of minus 1 is the first bit over the second, if that makes sense. So it's 3 over 2 because it's 3 times 2 to the minus 1. So 3 times 2 to the minus 1 is 1.5, which is 3 over 2. So hopefully that makes some kind of sense. And then we're just going to rewrite this equation as we did before. So 1 take x over 2 to the power of minus 1, take away 2, 1 plus x to the power minus 1. Okay, so that's the sort of form we need it in now. Now what, I'm just sort of running out a little bit of space. So what we've got here is we've got 2 binomial expansions we can do to the term of x squared. Now what we're going to do is we're going to do the binomial expansion of this up to x squared, take away the binomial expansion of 2 brackets 1 plus x to the power of minus 1 to the power of x squared. Okay, and we're going to take them two powers away from each other. So what I'm going to do, for time's sake, I'm assuming you don't really, you could just use a formula. So what I'm going to do is I'm just going to write the answer for this expansion, because I want to leave a little bit of room so I can keep all of the data, sounds fancy, isn't it? All of the information that we've wrote down on this one little whiteboard here, just so that I'm not squashed for space, because I'm lazy, basically is what I'm trying to say. So if you simplify this down, what we get is we get negative a half. I remember we're going in powers of, oh actually one sec, I think it's a better idea if I give you a minute to pause the video, just change my mind then, so you can have a go at that expansion there and do them two binomial expansions using a form of 1 plus a to the power n. So 1 plus a brackets power to the power n, sorry, them two expansions. Now one thing, just before you pause the video, if you haven't already, just do it as you normally would, and then for the first one you do that binomial expansion times all of that by 3 over 2, and then you do the binomial expansion of 1 plus x to the, and then close brackets to the power of minus 1, so that one there, and then you times all of that binomial expansion of that bit by 2, and you take them two away. So just to recap that, you do the binomial expansion of that times by 3 over 2, and then take it away from the binomial expansion of that times 2. So just give you a minute, well not a minute, a few seconds to pause the video, and then I'll just write the answers out so we can crack on with this video. Alright, so hopefully you've had a chance to pause the video. If not, I'll stuff you, we'll just carry on. So, let's go through the answers then. So the answers are, it's because it's ascending powers of x, it's minus a half, as I started to say before, plus 11 over 4, 11 quarters x. Oh, take 13 over 8 x squared, and we go on. If obviously I could, because we're only doing it up to x squared, when we reach 13 over 8 x squared, it's not going to be any more until we go above x squared, which it only wants to x squared, so we don't need to worry about anything greater than that. Now, we've answered the first part of the question. Just to reiterate the question, it said express the original fraction there in ascending powers up to the term of x squared, which we've done, tick, and state the range of values of x for which it is valid. Okay, now to do this we have to cast our minds back to the previous video in which I said for the valid, no, for God's sake, sorry, h, kills. If n is not a positive value, so because it's minus 1, if it's not a positive integer, then the values for a, which is the x bit, lie between minus 1 and positive 1. So what we're going to do is we're just going to do that with these two fractions here. So it's not fractions, so expansions. So I'll first do 3 over 2 times 1 take x over 2 to the power of minus 1. Now this a is x over 2. So if I sub that into our what we said before of minus 1 a plus 1, so it's between that fraction, we put x over 2. We need to times both sides of the equation by 2, so that becomes minus 2 x, so x is between 2 and minus 2, so that's tickety boo. This next one, it's 2 brackets 1 plus x to the power of minus 1. A is x, so it's just between minus 1a and positive 1. So there are your two answers. So that's how you'd work that one out. So hopefully that's makes some kind of sense to you. So all we've done is we mixed our partial fractions with our binomial expansions and proved the validility. But bit of a trick thing there. We're not quite finished. These are two values. They're very good. They're both values. Okay, but what does that mean? How do we finalise that? Well, one set of values is considerably bigger than the other. So what we need is, because it's not taken away, it's just one overall fraction, we just split it up into a takeaway. I'm not the kind of one that you eat. I'll show where mine is at the moment. So there's two values here. Now, there's one way of working it out, and we've got this range, and we did another way of. So basically, we've got two ranges here, and our overall range, because we did one fraction, not two, it needs to satisfy both ranges. Okay, so the best way of drawing this is a number line, or if you can imagine it in your head, it's just the numbers. So the biggest range we have is 2 and minus 2, and the smallest range we have is half of that, minus 1 and 1. Now this, between 1 and 2, and minus 1 and minus 2, we can't include that, because that only satisfies this part of the inequality here. It doesn't factor in this part of the inequality. But this, the smaller variant between 1 and minus 1, which I'm going to call n, just to confuse everyone, or z, whatever, just call it a letter, just call it z. Z, the smaller range, which is between minus 1 and 1, satisfies the first range and the second, because it obviously satisfies itself. So if it satisfies both, then that's perfect. So this is the ideal range. We could have just done this expansion here, but we needed to do both to make sure we had the total range that fitted both. Because if we just did this one, then this range could have been even smaller. So we may have been overestimating the range. Whereas when we've done the comparison between the two ranges, what we've found out is we've found an overall range that fits in both of them. And generally what it is, it's the smaller range. It's not always that case, but basically what I'm trying to say is a range that, so you could come, it might not be one of them two ranges, you might have to create your own range between two ranges, if that makes any sense. If I'm going on complete tosh here, just ignore me. Just realise that the range has to satisfy the two, so the overall range that x is between has to satisfy both of the ranges that we've found out. So to recap what we've done in this video, what we did was the question said that 5x take 1 over 2 take x, x1 plus x, or x plus 1, and it said express that in ascending powers of x up to x squared, so we knew we had to do some kind of binomial expansion for that, and state the range of values for which x is valid. Now, a couple of things we needed to know, so to recap the things you needed to know for that question, we needed to know how to simplify or show a partial fraction, which is the fairly easy one, as it's just two linear terms, not any quadratics in there or anything. And what we else needed to know is how to find the binomial expansion of up to x squared, and how to put it in the form of 1 plus a to the power n. And then what we also needed to know was how to find the validility of when it's not a positive integer, and then the range, and we needed to know the range of the two values that we came up with. Okay, so hopefully then you could just make a list on a piece of paper of them, of each of the points that I've just made there, if you know, just to recap the video, but that hopefully that makes some kind of sense. So as I said, that's the end for binomial expansions. The only addition to binomial expansion I'll be covering is probably some probably exercise 2.1 in your class book and some past paper questions. But as I've mentioned before, it doesn't matter if you don't have that book, I'll just list them anyway, but just for the benefit of the people who are in my class. Hopefully you've managed to survive that video, and we'll see you in the next one. And don't forget to like and comment if that's okay. Alright, we'll see you in the next video.